Hello and welcome to Physics 2005. Let's do the multiple choice. Alright, a ball is thrown in the air, traces a path as shown below. Which of the following statements is true? The velocity of the ball keeps changing. That's true because you can see the distance between each photo is getting shorter and then longer. The acceleration of the ball keeps changing. That's not true. The only acceleration on this ball is gravity. The velocity of the ball at the top of its motion is 0. That's not true. It's traveling in the x direction. And the acceleration of the ball at the top of its motion is 0. That's not true. So the answer here is A. Alright, question number 2. Why would a satellite in low orbit around Earth eventually fall to Earth? Alright, it's not a geostationary orbit. Well, that's not part. Gravity is too strong at low orbits. No, that's not true. Well, it's not too strong. The solar wind pushes it out of orbit. No. And the upper atmosphere gradually slows it down. Yes, that's true because it's going to be colliding with air, and it's going to generate friction. So energy is going to be transferred into heat, and thus it's going to fall back down. The initial velocity required by a space probe to just escape the gravitational pull of a planet is called escape velocity. Which of the following quantities does not affect the magnitude of the escape velocity? So remember that escape velocity is equal to the square root of 2gm, where m is the mass of the planet, over r. So in that case, B is the right answer here. The mass of the probe doesn't matter. Alright, a space probe B in a stable orbit around a small distant planet. The probe fires a forward-facing rocket that reduced its orbit speed by half. Which of the following best illustrates the subsequent motion of the probe? So its velocity is going down by half, so it can't be A. A depicts that it's getting faster, B depicts that nothing's happened, C depicts that its velocity goes straight down to 0. So I would select D, because its motion will be reduced, but not to the extreme of C. Alright, Napoleon attacked Moscow in 1812 with his cannon firing a shot at an elevation angle of 40 degrees. Napoleon then decided to fire a second shot at the same speed, but at an elevation of 50 degrees. Alright, so here's a tip for you. If two shots, if their angles add up to 90, they're going to have exactly the same range. Which of the following observations would Napoleon expect to be true about the second shot when compared with the first? The only thing that's going to be different is that the second shot is going to have a longer time of flight, because it's going to have more y velocity but less x velocity, and thus it will have the same range. Okay. Question 6. In a particular experiment, a long length of copper wire with very low resistance is rotated by two students. The ends of the wire are connected to a galvanometer, G, and a current is detected. Alright, which of the following is least likely to affect the amount of current produced? So this is producing back EMF because it's cutting lines of flux. And remember that the equation had its length, its speed, and the orientation. The equation said nothing about thickness, even though thickness does account for resistance. But in this case, I would pick B. Okay, a single turn coil of wire is placed in a uniform magnetic field B at right angles to the plane of the coil as shown in the diagrams. The coil is then rotated in the clockwise direction as shown. Which of the following shows the direction of the current flow in the coil as it begins to rotate? So it's not going to be B or C, because current is depicted to be rotating in the same direction. We know that this question is targeting motors and generators, and so our fingers is going to point down, and our thumb is going to point that way. Sorry for not being that descriptive, but when you apply the rule, A turns out to be the answer. So just do that and, you should be okay. Okay. A primary coil of a transformer is connected to a battery, a resistor, and a switch. The secondary coil is connected to a galvanometer. Which of the following graphs best show the current flow in the galvanometer when the switch is closed? So this is a DC power supply, so it's going to only experience a spike. So it can't be A, can't be B, can't be D, so it has to be C. Even though it does look funny, it's the only one that starts from 0, goes up, and then finishes at 0, while D here depicts AC current. Alright, 3 rings dropped at the same time over identical magnets as shown below. Which of the following best describes the order in which rings P, Q, and R reach the bottom of the magnets? Alright, so this copper wire is going to produce a back EMF because and it can do so effectively because it's a closed circuit, while copper cannot, and plastic has high resistance, so it's just going to fall straight through. Rings P and R arrive simultaneous, followed by Q. Although I had some complaints with this question from my teachers, saying that, even though it does have a slit, it will still produce back small eddy currents in the copper. But yeah, we actually have to do this experiment. Alright, a transformer is to be designed so that it is efficient. The heat by eddy currents minimized. The designer has some iron and insulating material available to build the transformer core. The windings are to be made with insulated copper. Which of the following design minimizes the energy losses in the core? Alright, so this is just a memory question. It has to be B. It can't be C because you're still going to get large eddy currents in those planes. And D will still get quite a bit of eddy currents, while A is, just a block. With the insulating material between the iron sheets, you're essentially making the eddy currents really, really small because it's perpendicular to the way that eddy currents flow, and thus you limit the area. So the answer here is B. Okay, this is just another memory question. I could probably answer it without reading the actual question. Which of the following statements about cathode rays does the apparatus provide evidence for? So this is providing that cathode rays have momentum simply because the momentum is transferred from the electron to the paddle wheel. So B. Alright, a family of curves below shows the relationship between the intensity of a black body radiation and its wavelength for various Kelvin temperatures. Yes. Okay. Who was the first to correctly explain this relationship? I believe it was Planck, and he suggested that light at atomic level was, or energy at atomic level was quantized. Alright. A doped silicon semiconductor has the following energy level diagram. What element is most likely used to dope? So it has a dopant level, so meaning it has an extra hole because it's near the valence band. If it was near the conduction band, then it will be an additional electron. So it would have a hole, and so the answer would be A, boron. Alright, 14. An FM radio station transmits a frequency of 102.8 megahertz. Was the energy in joules of each photon emitted by the transmitter? The energy, I can guess, is going to be quite small. energy is equal to hf. We don't know F, but we can replace it with C over lambda, and you'd get your answer. Yeah, I can't use the calculator while I'm using this recording tool. Okay, a current is passed along a square semiconductor rod as shown. Half of the current is carried by electrons and half by holes. Or you can just think of as the current carried 100% by electrons. Anyway, a magnetic field is then applied to the rod at right angles to its axis. Which of the following correctly describes the movement of the electrons and holes in the rod when the magnetic field is applied? They speed up, they slow down, that's not right. They move to the same side of the rod, or they move to the opposite sides of the rod. So when we apply our hand rule, we know that electrons go one way, but keeping in mind with holes are going in the opposite direction, but also have the opposite charge, meaning that they're plus charge. So opposite of opposite is essentially the same thing, right? So in this case, they would move to the same side as the electron. So C. Alright, and that is it. Alright, thank you.